Module 2 says to show that sine 2 theta is 2 tan theta over 1 plus tan square theta. So let's do that. So one thing I like to do is I like to start with my left-hand side. So you're always going to see me, right? LHS. LHS, left-hand side. The left-hand side is equal to sine 2 theta. Now sine 2 theta is the same as 2 sine theta cos theta. That's sine 2 theta. 2 sine theta cos theta. Everybody agree with that? That's just a double angle formula. Now look what I'm going to do next. Now I'm going to write up here tan theta. What is tan theta? Everyone knows that tan theta is sine theta over cos theta. I know I'm writing it a little small, but it's because it's not really a part of the proof. So if you were to cross multiply, you can actually see that sine theta would be equal to tan theta cos theta. That's all I'm saying, that sine theta is actually equal to cos theta tan theta. Aha. So look what I'm going to do. So what I'm going to do is write this out now as 2 times sine theta. I'm going to replace it as tan theta times cos theta. But no, cos theta times this cos theta is going to give me cos square theta. Aha. But cos square theta is what? Cos square theta, as I know it, is 1 over sec square. And so this works out to be 2 times square theta over sec square theta. This don't look like theta, let's fix that. 2 times square theta, 2 tan 2 tan theta over sec square theta. But then what is sec square? Sec square is 1 plus tan square. Alright, so now we can write that this is actually 2 tan theta over 1 plus tan square. Nice and easy, and that's how we get right hand side. Nice and easy, soft. So that's part 1. Part 2 now, part 2 says, hence or otherwise, solve sine 2 theta minus tan theta equals 0. Hence or otherwise, solve sine 2 theta minus tan theta equal to 0. Now, if we're solving sine 2 theta minus tan theta is equal to 0, then we really don't have any issues. All right, why we don't have any issues? That's because sine 2 theta is this identity right here. And so you can rewrite this now with 2 tan theta over 1 plus tan square theta minus tan theta is equal to 0. Now, I don't like when my equations equal 0, so I was going to bring over tan theta and then multiply through by 1 plus tan square. But you can just go ahead and do it from right here. So we're going to multiply through by 1 plus tan square. So we're going to multiply the equation by 1 plus tan square theta. If you multiply the equation by 1 plus tan square theta, it's going to automatically become 2 tan theta minus, now tan theta times 1, that's just minus tan theta. Then minus tan theta times tan square theta is minus tan cube theta. All right, so this is what we have now. So we have a cubic equation in tan. So let's go ahead and solve this tan equation. I don't like when this term is negative, so I'm going to multiply through by -1 to rewrite it as tan cube theta Now 2 tan theta minus tan theta is tan theta, but since I multiply through -1, it's just going to become minus tan theta. So I just get tan cube theta minus tan theta is equal to 0. I can then go ahead and factorize tan theta, and factorizing tan theta from it, I end up getting tan square minus 1. Tan square theta minus 1. And this is of course equal to 0. Now if I'm solving this equation, then it's either I'm solving tan theta must be equal to 0, or if tan theta is 0, the other equation is that tan square theta is equal to 1. All right, now if tan square theta is equal to 1, then this equation is telling me that tan theta is equal to plus or minus 1. Plus or minus 1. Now let's first look at when tan theta is 0. You draw your circle. You know that tan is positive in the first quadrant and the third quadrant. Then what is tan inverse of 0? Tan inverse of 0 is 0, and so the two solutions are going to be 0 and pi. That's from these two quadrants. Now looking at this now, since it says plus or minus 1, you're going to want the solution from every quadrant, every diggy quadrant, first, second, third, and the fourth. So first find tan inverse of 1, and they want the answer in radians. So tan inverse of 1 is going to be pi by 4. Then the solution in the second quadrant is going to be pi minus pi by 4. Then the solution in the third quadrant is going to be pi plus pi by 4. And then the solution in the fourth quadrant is 2 pi minus pi by 4. Nice and easy. So that's how we get this now. So finally we can write down our values for theta. So the final answer is going to be theta is actually equal to 0, or theta is equal to pi by 4. I'm just putting them in order. Or theta is equal to pi minus pi by 4, which is 3 pi by 4. Or theta is equal to pi, or theta is equal to, this looks like 5 pi by 4. Or theta is equal to 2 pi minus pi by 4, which is 7 pi by 4. Nice and easy. Nice. And that takes care of this question. Nice and easy, soft. Now all you're required to do is plug it in theta as 0, sine of 0 minus tan of 0 is 0, put in pi by 4, which is 180 over 445. Just checking the answers when you have sine 90 minus tan 90. Oh, pi by 445, yeah, this is fine. Try 3 pi by 4 as well. All of them is going to be right. All right, so that's the solution for theta. Nice. Now part B. Part B now is saying that express f of theta in the r cos theta plus alpha form. So let's write down f of theta. F of theta is equal to 3 cos theta minus 4 sine theta. Now to put it in the r cos form is very easy. First you need to find r, and r is equal to the square root of a squared plus b squared. So r is going to be equal to the square root of 3 squared plus 4 squared. The square root of 3 squared plus 4 squared, that's just the square root of 25, and the square root of 25 is 5. So that's r. The next thing we need to find is alpha. How do we find alpha? Alpha is tan inverse of b over a. So it's tan inverse of 4 over 3. So you put that in your calculator, and what are you going to get? Tan inverse of 4 over 3. You want it in radians. Getting 0.927. 0.927. And so finally, what we can then conclude is that f of theta is going to be equal to r, which is 5, times the cosine of theta plus alpha. So it's 5 times the cosine of theta plus 0.927. That's going to be f of theta. 5 cosine theta plus 0.927. After you do that, now it says, so this is part 1. Part 2 asking us to find, part 2a asking us to find the maximum value of theta. Now the maximum value of theta is 5. Maximum value is 5. The maximum value of a cosine function is the amplitude, and the amplitude is 5. Now they say find the minimum value of 1 over a plus f of theta. Now for the second part, look what we're going to start with. What I wanted to start with is to say that the function f of theta, it's always going to be bounded between 5 and minus 5. It's always going to be bounded between 5 and minus 5. And so if you add 8 to it, you're going to say that 8 plus f of theta is going to be bounded between, adding 8 to 5, 8 plus 5 is 13, and adding 8 to minus 5 is 8 minus 5, which is 3. And so 1 over 8 plus f of theta is going to actually be bounded between 1 over 3. So it's going to be now less than or equal to 1 over 3, but greater than or equal to 1 over 13. Once you are flipping, you change the signs, all right? And so what we can then conclude is that the minimum value will be 1 over 13. All right, so let's write that down in a formal manner. So the minimum value of whatever minimum value is 1 over 13. That's it. So the minimum value of 1 over 8 plus f of theta is 1 over 13. Nice, that takes care of that. Now let's go to part C. Part C is saying that given that the sum of angles of a triangle is pi, show that the sine of A is equal to the sine of B plus the sine of C. Now, first thing I want to start with is that A, B, and C are angles of a triangle. So let's work this out. Let's do this question. A, B, and C are angles of a triangle. A, B, and C are angles of one triangle. So if that is true, then clearly the angle A plus the angle B plus the angle C must be equal to 180 degrees. And so if I were to subtract B plus C, I would get that A is equal to 180 minus, in bracket, B plus C, right? That's how I would make A the subject. I'm then going to take the sine of both sides. And so what I'm saying is that the sine of A is equal to the sine of 180 minus B plus C. Now, what I'm getting then is the sine of A is equal to, now think of this as the sine of, think of it as the sine of A minus B. Think of this as the sine of A minus B. So this is going to equal to the sine of 180 times the cos of B plus C minus the cosine of 180 times the sine of B plus C. So what I'm getting now is that the sine of A is equal to, the sine of 180 is 0. So this works out to be 0 minus the cosine of 180 is minus 1. That's now minus 1 times the sine of B plus C. Nice. And so what we finally get now is that the sine of A is equal to minus become plus, so that works out to be the sine of B plus C. So the sine of A is the sine of B plus C. Nice and easy. Soft. Now since the sine of A is equal to the sine of B plus C, it is proven. Nice. Now let's look at the next part. For the next part, it says, show that sine A plus sine B plus sine C is equal to that thing there. Now all I'm going to do is, since sine A is equal to the sine of B plus C, then what I then know is, then the sine of B is going to be equal to the sine of A plus C, and then the sine of C must be equal to, the sine of C must be equal to the sine of A plus B. Nice. Hence, what does that mean then? Hence, the sine of A plus the sine of B plus the sine of C is going to work out to be the sine of B plus C plus the sine of B, which is A plus C, plus the sine of A plus B. And that's what we have. All right, the only thing is that the order is different. So let's know, but then now addition is commutative. So but addition is commutative. The order in which we add doesn't matter. And so the sine of A plus the sine of B plus the sine of C must be equal to the sine of A plus B plus the sine of B plus C plus the sine of A plus C. That takes care of question 3. Nice and easy. Soft. Nice. Now we move on to question 4. On with question 4. Question 4 tells you that a circle is defined by the equation x squared plus y squared minus 6x minus 4y plus 4 equals 0. And it says show that the center and the radius of the circle is 3, 2, and radius 3. So let's do that. All right, so a circle, it is defined by x squared plus y squared minus 6x minus 4y plus 4, and this is equal to 0. Nice. So what are we gonna do? First thing I like to do is group my x terms together. So I write it as x squared minus 6x plus y squared plus y squared minus 4y plus 4. I'm then going to complete the square among the x terms to get that this is now x minus 3 all square minus 9 plus, completing the square among these now, I half the power to get y minus 2 square, then you subtract 2 square, which is 4, plus 4, and that's equal to 0. So now I can put it in standard form. So putting it in its standard form, it's gonna be x minus 3 all square plus y minus 2 all square, and that's equal to r square. But what is r? In that case, we'll bring it over, bring over the 9, it's going to be plus 9 is 3 squared. Okay, and so now we have the center. So hence the center looks like 3, 2, and the radius, which is 3, and the radius is 3. Nice, that's it. Okay, now let's look at the next part now. It says, show that the tangent to the circle 6, 2 is parallel to the y-axis. To do this question, I always like to draw a circle. I just like to draw a circle to see what's going on. I have a circle and the center of that circle is, it said the center is 3, 2. Then you have some point 6, 2. 6, 2 is directly here. This will be 6, 2. Without even working out the question, I can see that the tangent is, of course, parallel to the x-axis. Parallel to the y-axis, sorry. This is not 6, 2, sorry. I put the wrong point. 6 would be going across here. My bad. My apologies. This is 6, 2. All right. And this would be the tangent. All right. That would be the tangent. Clearly, it's parallel to the y-axis. The y-axis would be right here in reality. This would be the y-axis in reality. And x-axis would be somewhere here. Clearly, you can see it's parallel to the x-axis, but let's go ahead and work it out mathematically. So first thing is, if it is parallel to the y-axis, then the gradient of the tangent is infinity. All right, so that's what we need to show. So if the tangent at 6, 2 is parallel to the y-axis, then the gradient of the tangent line must be undefined, or in other words, infinity. So let's show that. All right. First thing we can start with is by finding the gradient of the normal. Now the gradient of the normal is equal to, the gradient of the normal is y2 minus y1, which is 2 minus 2 over x2 minus x1, which is 6 minus 3. 2 minus 2 is 0. 0 over anything is 0. So the gradient of the normal is 0. If the gradient of the normal is 0, then the gradient of the tangent is equal to minus 1 over the gradient of the normal, which is undefined. This is undefined. So hence, the tangent is parallel to the y-axis. That's how you do that question. Nice and easy, soft. Now let's look at part B. Looking at part B, it says that show that the Cartesian equation of the curve has parametric equation 4x equal to y squared plus 10y plus 24. So let's go ahead and do that. So you have x is equal to t squared plus t, and then you also have that y is equal to 2t minus 4. All right, so all you need to do now is from this one right here, you can transpose for t. Transposing for t, you'd say that you'd bring over this 4 over here to get y plus 4, and then you divide by 2. So y plus 4 over 2, that would give you t. So what does that mean? That implies that x is equal to, substitute for t, y plus 4 over 2. So x is equal to y plus 4 over 2 all squared plus t, and t is y plus 4 over 2. All right. So now continuing, we're going to get x is equal to, we're going to have to expand out this part. Now it's going to be first term squared, which is y squared plus twice the product of the 2, which is 8y, plus the second term square, which is plus 16, divided by 2. 2 square and 2 square is 4, plus this is now y plus 4 over 2. Now the equation that they showed had 4x, so all we need to do is multiply through this equation by 4. If we multiply through by 4, it becomes 4x is equal to, that becomes y squared plus 8y plus 16, and then multiply 4y over 2 just becomes 2y, and then 4 times 4 is 16, 16 over 2 is 8, so you get 2y plus 8. Good. So finally we can conclude that 4x must be equal to y squared. Now 8y plus 2y is 10y, so y squared plus 10y, 16 plus 8 is 24. And we showed it. This is now the Cartesian equation. Nice and easy, it's proven. Soft. So finish. That's 4 marks. Next question. It says that express vector AB and vector BC in the form xi plus yj plus zk. All right, so let's do this question. Let's make space over here. All right, we don't need to be wasting any space. So we have it that vector AB is OB minus OA. All right, vector AB is OB minus OA. OB minus OA, that's just going to be, looking at the coordinates, it's going to be OB is 1, 2, minus 4. That's vector OB. And we're subtracting vector OA. Vector OA is 3, minus 1, 2. Doing this easy subtraction, we get that vector AB is 1 minus 3, which is minus 2. 2 minus minus 1, minus 1, that becomes 3. Then minus 4 minus 2, which is minus 6. That's vector AB. Nice and easy. Next we need is vector BC. Vector BC is going to be equal to vector OC minus vector OB. So vector BC is vector OC minus OB. Nice and easy. Now since this is vector BC, OC minus OB, then let's go ahead and do it. Vector OC is -1, 1, -2. And then we're going to subtract vector OB. And vector OB is 1, 2, -4. Nice. So let's go ahead and do the subtraction. Oh, remember they said they want it in IJK form, so I don't want it to lose any marks. Let's rewrite it as 2i plus 3j minus 6k. Don't want it to lose any marks. So 1 minus 1 minus 1 minus 1 is -2. Let's put I already. 1 minus 2. 1 minus 2 is -1. J. Then -2 minus -4 is 4 minus 2, which is plus 2k. That's vector BC. All right. Nice. Now it says, show that vector R is perpendicular to the plane through A, B, and C. So what I'm going to do is, let's say this is plane. Let's say this is the plane with the different points A, B, and C. All right. If that is a plane through A, B, and C, and then you have this line, which is vector R. Let's say this is vector R, and this is the plane. We need to show that the plane is perpendicular to this line. So you have the points A, B, and C. I'm just making up some stuff here. This could be A, this could be B, this could be C. Now, if the plane and this line is perpendicular, then that means that any two lines or direction in the plane, that means vector AB and vector BC must be perpendicular to this line as well. And if they're perpendicular, then all we need to show is that R dot AB, we need to show that this is 0. And we need to show that, we need to also show that R dot BC is 0. If the dot product for both of these lines are 0, then hence this vector is perpendicular to the plane. So let's go ahead and show this. This is what we need to show. So let's try to do that now. Vector R as we see is 0, -16, -8, and we're taking it with the dot product of vector AB, and the dot product of vector AB is -2, 3, -6. This is -2, 3, -6. Taking it with the dot product, we're getting 0 dot -2. 0 times -2 is 0. Then I get -16 times 3. And you're getting -8 times -6, that is plus 48. And this is working out to be 0. So absolutely, yes. So far they're perpendicular. All right. Let's try this one now. R dot BC. R dot BC is 0, -16, -8 dot BC. And what is vector BC? Vector BC is -2, -1, 2. -2, -1, 2. That's equal to 0 times -2 is 0. -16 times -1 is plus 16. Then -8 times 2 is -16. And all of this work out to be 0. All right, so hence, so now we can conclude hence R is perpendicular to the plane. So we can make our conclusion that R is perpendicular to the plane. Next thing it asks now is to hence find the Cartesian equation of the plane. Now, in order to do this, in order to find the vector equation first, we need a normal. Now, since R is perpendicular to the plane, then R can be a normal to the plane. All right, since R is perpendicular to the plane, then R can be a normal to the plane. Then we know that the vector equation of any plane is R dot n is equal to E dot n. All right, and so it works out to be R dot n, in this case, n is 0, minus 16, minus 8, and that's equal to A dot n, where A is a known point on the plane. You can use any one of the 3 points on the plane. So A, you can use either B, point B, you can use point A, or you can use point C. Let's say you want to use point B, 1, 2, minus 4. 1, 2, minus 4, dot n, and n is 0, minus 16, minus 8. So working out this dot product, we're going to get 0 plus 32 minus 32. This is going to be working out to be minus 32 plus 32, which is equal to 0. And so hence, that implies that the Cartesian equation is going to be, remember R in general, remember what R stands for. R stands for X, Y, Z. So in reality, R stands for X, Y, Z. And so the Cartesian equation is going to be 0 times X is 0. So it's minus 16y minus 8z is equal to 0. That's the equation of the plane. We can divide through by negative 8 to say that the plane really and truly is 2y plus z equals 0. All right, that's the equation of the plane. That's a Cartesian equation of the plane. Nice and easy, soft. Now that we have the Cartesian equation of the plane, we're good. We're absolutely good.